Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Hawaiian Volcanic Eruption, Silicon and a Planet's Increased Density with Depth. Now, the volcanic eruption, which is ongoing on the big island of Hawaii, has been characterized by lava flows which have greatly increased in speed. For this to occur, the lava would have to have become less viscous or less thick, which indicates that it is hotter. Hotter lava would indicate that it is coming from deeper within the earth. Now, high viscosity, in other words, thick lava, is associated with higher silica content. Silica is a mixture of silicon and oxygen, or it's silicon dioxide. Thus, fast-flowing lava would be less viscous, more liquid, and have lower silicon content. And here you see this lava flow in Hawaii, and it has become very fast-flowing, this lava. And this indicates that it is higher temperature lava that is now coming out of this volcano. And it must therefore come from deeper within the Earth, since the Earth is expected to get increasingly hot as we approach the core, where energy is generated as a result of radioactive decay. And you may look at Article 240 entitled Planet X System Effect on Radioactive Decay and Heating of Planets for more details on that. Now, silicon has an atomic number of 14 and an atomic weight of 28. So it has 14 protons and 14 neutrons in its nucleus and is thus a light element. Since hotter lava, which should come from deeper within the Earth, has a lower silicon content, this suggests the silicon is less abundant deeper in the Earth. This agrees with the fact that celestial objects are denser as we move down towards the core, as lighter elements like silicon would be more abundant in the object's layers close to the surface, and heavier elements would be more abundant in the layers closer to the core. And this agrees with the formation of celestial objects so that they have increasingly denser layers as we move towards the core, as I proposed in Article 185 entitled Stellar Formation, Stars are Formed from Light. An idea which follows the theory of electrogravitation described in Article 182 entitled Einstein's Dream Realized Unified Field Theory of Electrogravitation, which came from observing stellar cores interacting with the Sun. And you may look at Article 181 entitled Stellar Cores and Deciphering Gravity, with some details on how these ideas came about. And here we have illustrated what a celestial object is supposed to look like. It would have a very dense core and then layers that are less and less dense as we move towards the surface, and finally an atmosphere and a high in electrons layer, a negative outer layer. And heavier nuclei, which are denser in protons, form the dense interior of a celestial object. Less dense nuclei form increasingly less dense layers around the central core. So this layer would be less dense than the core itself. This layer would be even less, and so on as we move towards the surface. Hydrogen is the least dense of all nuclei, which is why stars seem to have hydrogen on the outside, or a lot of hydrogen on their surface or above the surface. And silicon is also a light element and should be more abundant closer to the surface of the object and be less abundant in its deeper layers. And you may look at Article 185 entitled Stellar Formation, Stars are Formed from Light for more details on how this came about, this idea that all objects, including stars and planets, have very dense cores. They generate energy in the cores through radioactive decay and have solid but increasingly less dense layers above the core. And this is for stars and planets. And here we see one of the stellar cores, which is making its plasma connection to the sun. It's drawing material from the sun through this connection. These objects draw energy from the sun. Eventually, they obtain an atmosphere by drawing material from the sun. We see another one here. This one has already developed this kind of atmosphere by drawing material from the sun. This object is about half the size of Jupiter. So now this the ongoing eruption, which is increasingly with its increasingly faster flowing lava, indicates that magma from deeper within the earth is finding its way to the surface, in agreement with the fact that stellar cores hosted by the earth, and you may look at Article 243 entitled Earth hosting at least 3 Planet X system objects for more details on how we know that these objects are now being hosted by the earth, are drawing energy from the earth in the same way that these objects that are being hosted by the sun are drawing energy from the sun. And you may look at Article 143 entitled Planet X Traverses the Sun, Irrefutable Evidence for more details on that, and slowly destroying it. And then you may look at Article 195 entitled Stellar Cores in the Dying Sun for more details on that. The withdrawing of photon energy by the stellar cores from the Earth causes the Earth's core to generate more heat. And again, you may look at Article 240 entitled Planet X System Effect on Radioactive Decay Rate and Heating of Planets for details on that, which results in all layers heating up, and in particular the Earth's outer core, which is made of molten rock or magma, to heat up. And this is illustrated here with this diagram. We have a stellar core which is drawing energy from the Earth. It does so through its gravitational field overlapping the Earth's gravitational field. These objects have very, very small gravitational fields, though. They are very weak gravitationally, so they have to come very close. And this is why they actually would come into contact with the Earth's atmosphere, just like they would come into contact with the sun's atmosphere. And then they draw energy, and they draw energy directly through absorbing photons, and they draw energy through drawing matter. And as they draw energy, this causes the core to generate more and more energy. As the energy of the Earth drops, the radioactive decay rate increases, so more energy is generated. So that means that more energy comes out from the core, and this energy is associated to temperature. So that means the core will get hotter, and so will the layer outside of that, or next to that, which is the Earth's outer core. And this is a liquid layer made up of molten rock and therefore magma, and this would have now an increase, or experience an increase in temperature. It would expand. It would then seek for ways. There would be increased pressure, so it would have a tendency to find a way out of that layer within the Earth and move through channels towards the surface, leading to volcanic eruptions. So this will in turn increase the pressure, as I said, and lead to this magma to flow, and it may lead to volcanic eruptions. And The pressure is or would be increasing all the time as more and more energy comes from the core. So we could possibly get magma to continue to flow indefinitely and increasingly faster as magma from lower in the earth gets into the flow chambers underground. So it's possible that this is what is occurring in the case of the Hawaiian volcano. In other words, that magma has found an outlet to the surface from the outer core of the earth all the way through the different layers of the earth to the surface at the Hawaiian volcano. And in this case, this eruption is not likely ever to stop. It will continue as long as there are stellar cores pulling energy from the earth, and this will continue until the earth has run out of decay elements, out of nuclei that will still decay. And once the earth has run out of energy, then basically it has turned into a dead object as well, and it will turn into a stellar core. So in conclusion, the fact that faster flowing and therefore hotter lava has a lower content of silicon agrees with the fact that faster flowing lava is coming from deeper within the earth and thus from layers which have higher density of matter. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.